Hello, good morning, good afternoon, good evening, wherever you're joining us from. This is Jim McKeith, and thanks for joining us today for this webinar. Today's webinar is rescheduled from last week. It's Miguel Moreno presenting on working with the Windows 10 runtime. Miguel is an Embarcadero MVP, and he's presented in the past for us on a number of webinars, so happy to have him here again today for this. I have put in the handouts pane, you can get access to the slides that Miguel's sharing with us today. So you can download those. Also, there is a link to the full series, which we have some more that I'm going to be adding on there today, more upcoming webinars. So check that out and sign up for those webinars as well. We're doing a special joint webinar with Microsoft next week, where they're going to show some of the new features on Windows 10, and Marco Cantu will show you how to use those from your favorite development tools. So that should be a fantastic one. Really looking forward to that, and I'm sure you'll get a lot of value out of it. And so if you do have any questions as they're going along, put them in the question panel to the right. Miguel's presenting this live, but I'll be here to help answer questions, and at the end we'll do a live Q&A session as well. So with that, I'm going to turn it over to Miguel for working with Windows 10's Windows Runtime.
Hello everybody. My name is Miguel Moreno, and I'm a MVP with Embarcadero Technologies. I'm going to show you working with Windows 10's Windows Runtime. Well, first of all, this is a quick view of the agenda. First, I will show you the Windows architecture strategy. Then I will show you what is the WinRT, Windows Runtime, which is also called the Universal Windows Platform, or UWP. And then the good question, why should we care about it? I'll do a comparison of the Windows RT versus, or UWP versus Windows 32, COM, and .Net. Then I will give you a latest snapshot of what's the ever-moving strategy with Windows from Microsoft. And then I will show you the components included in RAD Studio that are based on the Windows Runtime or WinRT. First of all, the Windows architecture strategy started with the Windows 32 API. The Windows 32 API is just a 32-bit version of the very original API introduced with the original Windows 1, 2, 3, until we came to Windows 95, then it switched to 32 bits. But other than the change to 32 bits, the API naming conventions stay basically the same. And you could see that on this architecture, each compiler is using its own runtime libraries and calling directly machine code, assembler code, and then finally doing the code to the Windows 32 API, which are just very simple non-job object-oriented routines that are included and since then have become the de facto standard to compile any program in Windows. Now, regardless of the technology and regardless it's not so modern, it's valid to say that the robustness of the Windows has been proven over time. We're still using Windows 32 up to today, to the point that when Windows switched to 64 bits, they kept the naming exactly as it was in Windows 32. We all know that the System 32 on Windows 64, which kept the same System 32 even at 64. So that just proves that it has become so standard that even Microsoft didn't want to change any naming when switching to 64-bit. In this application, every language has its own compiler, interpreter, runtime environment, libraries, etc. Now, you might remember that this has been expensive to implement because each language has its own library, its own runtime, its own implementation of how to talk to the Windows platform underneath. So the interoperability of the applications and the languages was very difficult. So it was very difficult to benefit from innovation in another island. Let's say you wanted to take advantage of a component made in another computer programming language. It was very hard to do. Not impossible, but really difficult to do. After that, we had COM. COM was a big improvement by Microsoft. It stands for Component Object Model. So this platform allowed to introduce a binary interface for interoperable components. For the first time, the Windows environment and ecosystem had a way to make interoperability between languages. So there was cross-language component libraries. There was a rich application integration. At the beginning, you might recall that those components were called OLE or OLE components and were advertised a lot and became very popular, especially with the Windows Office applications that use these components extensively. Later, OLE became OLE2 when they made a revision to this strategy. And finally, with introduction of the Internet components based on their Internet Explorer, they made a last change to ActiveX components. But basically, all of this is still using the COM strategy, the COM architecture. This became also the foundation for Visual Basic applications. The original Visual Basic also, all of them are based on this technology. Then, because of the popularity of Java, Microsoft introduced .NET with two strategies at the same time. One was to create a common runtime, the common language runtime. Also, you had a one singular platform being shared by languages on the top. So the main new language that they introduced to compete with Java was C#. Even Delphi went that way. You might remember we had Delphi for .NET for some years, trying to follow this trend that Microsoft was telling us to follow with .NET, which means managed code. I'll show you here. There was a common language runtime with a class library and languages that can compete with Java. With this strategy, building new languages should be easier. There was a strong cross-language interoperability. Many languages benefit from the Internet-ready class library. For the first time, there was in Windows available a robust, unique, standard Internet talking and ready library that was not available before. And finally, the CLR, the Common Language Runtime, became a standard and become platform independent. To the point that later, if you are aware of this, we had Mono, which was a porting and cloning of the CLR over the Linux platform, and nowadays is being used by Microsoft. Finally, Microsoft acquired the original team that was developing Mono and converted that into Xamarin. Xamarin nowadays is actually the Mono team, but now under the Microsoft's own umbrella. And now they are promoting this as the way to have a cross-platform development by using .NET languages on any platform that supports Xamarin, formerly known as Mono. But it didn't happen. This is what actually is happening with .NET today. The original target for Microsoft is that everybody would be switching over to using .NET and develop everything on top of .NET. But nowadays, yes, we cannot deny that .NET has some success and has been embraced by a lot of corporations and companies, but it wasn't exactly what they meant to be, because we still have native compilers, C++, Delphi, but at the same time, we have new players. So C++ is still strong, and JavaScript is the new player, which was not considered at the beginning. .NET very often is just a thin wrapper around OAS services. Native C++ is still very important, but it cannot benefit directly from .NET libraries such as XAML. JavaScript has become popular and the de facto standard for platform independence. So when we review it now, .NET library needs some redesign. And the idea is to use WinRT for the new world. So let's introduce Windows Runtime. The shortened naming convention is WinRT. Windows Runtime combines what's great in COM and .NET. It's a binary interface for language interoperability. It has metadata management, very similar to .NET. Actually, it borrowed exactly the same format that .NET uses for the metadata. So they're taking the good things from .NET and just incorporating it into this new architecture and platform. We can think of it as a new COM, component object model, and as a natural part of all languages and platforms. So it becomes the new foundation for .NET, C++ native, and JavaScript, and also Delphi and C Builder. So this is building a new class library on the new runtime. And it leveraged the opportunity to do a cleanup of the library compared to .NET. And the most important thing that we should see on this new platform is that it doesn't enforce managed code, which seems to be the big key issue of why many developers did not embrace .NET fully. Because when you really want the most performance of your program, you still need to be on native code. So let's avoid the confusion. What exactly is WinRT or Universal Windows Platform? Well, it's an application architecture introduced back in Windows 8. It was expanded in Windows 10, and then they renamed it to Universal Windows Platform, or UWP. So Universal Windows Platform and the Windows Runtime, WinRT, are the same thing. Only the Universal Windows Platform, they added features for the Microsoft Store. And it's an unmanaged code application programming interface API. This means it's native, so it runs fast. It's based on the component object model. So it took the good ideas and the good design of the component object model, but they just modernized it and made a better framework with more readability and taking the latest features given by C++, now that we have the new versions of the language, namely C++ 17 is being used for the base C++ interface into the new Windows RT platform. So the applications are run within a sandbox. This was in the original design. So it means that for some key features, it requires user approvals. It will show on the screen confirmation by the user, and it had restricted file access. Normally, you should only access documents, your images folder, but you could not have access to the root drive and the root folder, things like that. That was the original concept of Windows Runtime when it was introduced. One key feature is also that it's asynchronous, meaning that by design, one of the rules is if any of the interfaces has the possibility to last more than 50 milliseconds, then it should run asynchronously. So that means that when you are calling that piece of interface, you should give a callback routine so it won't block the code. And this is by design, something that was not enforced in the very original good old Windows 32 API. And the idea originally by Microsoft is that applications will be distributed through the Microsoft Store. Now, what is not Windows RT? This is part of the confusion by using very similar names. Windows RT is not the version of Windows that was included in the first ARM-based Surface tablets. And it's also not a managed code API or subsystem. Therefore, it's also not a subsystem or feature of .NET. And it's not also a Visual C runtime library. Many people confuse it with the Visual C++ runtime for Microsoft, but no, it is not. That's a completely different thing. So why should we care about the Windows runtime? Well, Windows Runtime, or WinRT, is the preferred architecture of API for Windows development since it was introduced back in Windows 8. So the original design by Microsoft is that new features and components of Windows would be implemented only in Windows Runtime, WinRT, or Universal Windows Platform. That was the original concept. And then these applications should be distributed through the Microsoft Store. It would introduce Windows notifications, live tiles, otherwise called as the Metro interface. And they also introduced a new visual framework called XAML. So that was the original design of why they introduced in the Windows RT. And at that point in time, no further development would be done on the good old Windows 32 API. So this is a quick comparison of Windows Runtime or Universal Windows Platform versus the good old Windows 32, Win32 versus COM, Component Object Model, and versus .NET. The code type in Windows 32 is native. In COM is also native, but in .NET is managed. So now with Windows Runtime or WWP, we are going back to be native for performance. Windows 32 originally was not object-oriented. COM, .NET, and Windows Runtime are object-oriented. The original Windows 32 API had no official definition or contract. So nothing was defined on the API itself. You always had to refer to the original documentation, but there was nothing provided by the API themselves. In COM, you might remember we had the type library, which is a registry maintained by the system, by Windows, where you have registered the interfaces that COM allows you to call and to interface with other objects. But in .NET, they took that concept even further, and they introduced the metadata that is a part of the standard of any component created in .NET. So .NET always publishes all its own definitions of every API you create, and this has proven to be so good that they took exactly that kind of metadata for Windows Runtime, and it is being the original metadata in .NET is stored in the .NET platform, but in Windows Runtime is stored in separate files with the extension WinMD, which stands for Windows Metadata. And one key thing that also was improved since Windows 32 is the original Windows 32 wasn't exactly non-blocking. You could block if you delayed on not making good management of the APIs and being wise of being some asynchronous calls. That COM by design, COM, Component Object Model, was non-blocking. So you should always be calling it and with callback routines. .NET is also non-blocking, and Windows Runtime stays non-blocking. So basically what you can see here is that they took the idea that they had and forced us to follow with .NET, but they went back to native code. Now, this is a quick example of how Windows 32 application looks like if you are coding directly by calling the API routines. And this might be familiar to some of you that have to code either with Visual C or with the original before Delphi was introduced, before Delphi and C Builder were introduced. This was the only way to create a Windows application, was to create a C, not even a C++. This is a C code calling the Windows 32 API. Windows 32 is not coded in C++. It's a standard C. So you can see those Hungarian style of coding, of calling the variables, the naming convention introduced by the Windows 32 API, and non-object oriented. So it was very cumbersome and very difficult to create this kind of applications. And now I will show you how a Windows Runtime application looks like now. For those of you that are familiar with C++ Builder, might see that it's very similar, even to, if you notice, to the VCL or FMX. You can see now that it looks very clean, very nice. It's with event handlers. And one thing that they are doing with Windows Runtime is it uses extensively the interfaces. And that's why they took exactly the COM, the Common Object Model architecture, based purely on interfaces for the definition of what functions, methods, and routines you can call for each one of the objects. So yes, one big change that you can see once you switch to the Windows Runtime at the C level is that number one is now C++ enforced. You are now enforced to use object-oriented programming. And number two, everything is based on interfaces to call the available routines and methods for each one of the classes and components. So big improvement. too many APIs. Yes, we have Windows 32, we have COM, we have .NET, and we have Windows Runtime. But the good news is that you don't need to worry about how to implement or use any of these APIs, because both the Visual Component Library, the VCL, and the FireMonkey framework, FMX, in RAD Studio, isolate the developer from this complexity. From the very beginning, we have a very well-designed object-oriented architecture. It is implemented for the two most efficient natively compiled languages, Object Pascal for maximum productivity and C++ for maximum performance. The components and classes provided by these frameworks do the interfacing with the appropriate APIs under the hood. You don't need to deal with them. To the point that let me show you what the C++ developers' impression is about Windows Runtime. I extracted this from forums of professional C++ developers and what they think about the introduction of the Windows Runtime at its time. One of them says, what I like about C++ Windows Runtime was that it finally seemed to be something similar to C++ Builder, native and access to a proper object-oriented framework, not the MFC ATL stuff, referring to the Microsoft Foundation components and the active type library. So this is something that we all know. We all coming from using Delphi and C++ Builder. It's much, much easier to use these libraries compared to what Microsoft has offered in the past. So for once, they are finally catching up. I extracted this comment from another C++ developer. Maybe I should not be saying this on C++, but for me, the sadness is that we didn't get Windows Runtime with .NET native already from the beginning. Embarcadero already had it with VCL under Delphi C++ Builder combo. So it isn't as if Microsoft couldn't have done it. So they are recognizing that definitely Embarcadero had the edge. Something that we all know as Delphi and C++ developers. Now I will show you the ever-moving strategy with Windows. I just show you what was the original idea of Microsoft with Windows Runtime when they introduced it on Windows 8. These applications would be running on Sandbox, and they would be deployed only on the Microsoft Store. There would be no further development of the Windows 32 API. So they were forcing everybody to change to Windows Runtime. Now, again, to us as Delphi and C++ developers, that was not an issue because all the changes were introduced for us by the Embarcadero developers. All of those changes were implemented under the hood in the library. So basically, we don't suffer about these changes. But the hardcore C developers that don't use C++ Builder or Delphi do suffer because they need to support all these APIs in the same application. And that is really very difficult to do, especially when you have legacy applications. So Kevin Gallo, which is the corporate vice president of Windows Developer Platform, has recently said that
So turns out Miguel had a power failure, so he is rebooting and getting back in right now. So hold on tight and he'll be right back. Okay, looks like he's back. So I want to make him presenter again, and we should be going here in just a second.
Okay, thank you. Sorry about that. There had a very unexpected slight power outage, and somehow it hit my computer. So I'll repeat from the point I was at. Is Kevin Gallo, corporate vice president of Windows Development Platform, made these statements, these remarks on a recent interview. In 2012, with Windows 8, we introduced a new framework to modernize the Windows 32 API called Windows Runtime. And at that time, this was the preferred way to develop in Windows, and basically abandoning and deprecating the Windows 32 API. In the middle of 2015, with the introduction of Windows 10, the Universal Windows Platform was born. And at that time, they introduced all the new features to add these applications to the Microsoft Store. The problem is that at that time, only if your application was developed with Windows Runtime, it could be added to the Microsoft Store. No other way to do it other than sticking to the Windows Runtime. There was a lot of complaints by the C developers that were using Windows 32, and they had these huge applications that were very difficult to migrate to the Windows Runtime. Therefore, in 2015, we announced Project Centennial, later renamed to Desktop Bridge, a set of tools that allow developers to bring their existing apps, Windows 32, to the Microsoft Store. That's based on so many complaints by the developers that how could they do that and abandon them for not being able to distribute an application that was made in Windows 32 in the Microsoft Store. So finally, Microsoft realized that legacy code and legacy applications that are still running and still under active development cannot be ignored so easily. Then, lately, Kevin Gallo says, we want to undo some of the effects of the massive divide between Windows 32 and Universal Windows Platform, Windows Runtime, by adding modern desktop elements to Windows 32 apps. So finally, they are acknowledging that it's not working well for them to forget the good old Windows 32 API so easily. So forcing developers to move to Windows Runtime for old applications, for old apps that are still out there is simply not working. So they have finally acknowledged. So all the new visual components and new features that we enjoy in Windows 10 and Windows 8 that were previously only available with the Windows Runtime, they will finally be porting them to be available under the Windows 32 API. So any developer would be enjoying these features regardless whether they're using the Windows Runtime or not. But then again, for us as Windows, Delphi and C++ developers, we shouldn't care that the good job has been done already by the Embarcadero developers of pointing to the right API under the hoods. So the last statement made by Kevin Gallo is, by the time we are done, everything will just be called Windows apps. And what's my point of highlighting this to you is because the original idea of Embarcadero of promoting the Windows 10 runtime is because Delphi and C++ were the only, maybe, I don't know if there's another one, but known to me, the only library and platform and developer tool that introduced immediately the new Windows Runtime visual components and features like notifications without forcing you to change any single thing. In other words, you could stay with a VCL or you could stay with FMX and you immediately had these components available. All the hard work and the dirty work has been done under the hood by the Embarcadero developers. But now, finally, seems that there would be no distinction. In other words, any developer that is not using Delphi or C++ Builder, especially those that are using the old Windows 32 applications, will also be able to enjoy this. So finally, I will show you what are the Windows Runtime components in RAD Studio. These have been presented over and over since they were introduced. There has been some minor changes, so I will do a quick recap of those components so you know which ones you had already available in Delphi and C++ Builder. The components that you have available in RAD Studio, both in Delphi and C++ Builder, is the notifications, which are implemented with the T-Notification Center and the T-Notification components, share contracts by the T-Sharing contract and share contract components, the activity indicator, relative panel, card panel, search box, split view, toggle switch, and the daytime pickers. Now, all these are implementing the new look, and some of them are completely new, like the notifications and share contracts and the activity indicator. Some of them are reintroduced to show you the new look and feel and styling introduced by Windows 10, like the daytime pickers. Now these are following the new look and feels and user interface introduced by Windows 10 in the Windows Runtime. So now let me show you this on how you can use them in Rat Studio. First one, the notifications. These applications are available in your demos folder. So you get notifications by using these buttons. You can also cancel the notifications. If one notification is acknowledged, you can get some feedback. So all these features are available by using the component T notification, and it will perform the same as the notifications that are included in Windows 10. So you see notifications here. And under the hood, you could see that is a simple VCL component. And to us as Delphi and C++ developers, there's nothing special. We didn't even need to know that there was a new architecture Windows Runtime under the hood. But the explanation made to you is that just to show you how simplified life is for us as Delphi and C++ developers. Okay, so the next component I'll show to you is the contracts. So you have two types of contracts. One is done through a component where you can share the information that you have, and it gives you the option of how to share it. You can, for example, do it via mail. Then once you have your credentials on email, then you can share the information. It's worth noting that the sharing contract has been enhanced in Windows 10, and now you also have this feature in the Windows Explorer. So in Windows Explorer, you can have a file and do some sharing. So this panel that is available now in the File Explorer from Windows is exposing the same capabilities and features from an endpoint of view. But the good thing is that you have this component available if you want to do it from inside your own application, and you will show exact same features that you have here. So you have two ways. One is using the component. Another one is calling the interface directly. You can call the interface directly from your application without using the component. Both are giving you the same features, the same results. Let's try now with OneNote. So it will open and share your information. We have the activity indicator. You may recognize it because this is the one that is shown by the system, by Windows, when you start it up. So now you have it available in your applications whenever you want to show to the end user that some activity is being performed in the background, so they can see that your application is not dead. And you can change the styling. There's 3 styles. The standard momentum dots, the rotating sector, and the sector ring. And all of them are different sizes. The next one is the relative panel. This panel introduced the feature to automatically align the components with these properties that you have available. So like this, you are selecting whether you want the component to be fully to the left, at the center of the form, or totally at the right of the form. Also, whether you want it at the top, you want it at the center, vertically aligned, or at the bottom. So all these features are available with the relative panel. It's an improvement over the standard simple panel that allows you to create a responsive native application in Windows. And responsive meaning that whenever you change the size and width of the form, the component will stay the same. For example, if we select the component to be on the center, no matter how we resize and move the window, the component will always stay at the center. This is what nowadays developers call a responsive application. That means it adapts automatically to any change on the form size, be it width or height. So now you have this available with the relative panel. The next component is the card panel. Card panel is a simple component that allows you to have a card style panel to show like kiosk style of applications. Before you had to manually code it using either a tab control or a page control, but now this control is already introduced by you. You have two components, the card panel itself and the card component. And then it makes it much simpler and easier to create these type of applications. The next component is the search box. So it's simplifying the look and feel of a search box, to which you can have two types of indicators. One of them is standard text box search, or you can indicate that it's an audio search. Now, that doesn't mean that this is a recognizing speech. No, it's only a visual indicator. You need to handle it anyhow. So whenever the search box is activated, then on this sample application, you can see that the event has been called. And the event being called here is an on search event. You can see here in the component, I select the component and you have the on-invoke search event specially created for this component. Then you handle here the search that the user wanted to perform. Next component I will show you is the split view. This component replicates the look and feel of many mobile applications that you might be familiar with now. And now you finally have them available in standard VCL applications. So the idea of this split view is that you have this side panel, which is customizable. You can have it docked, meaning that whenever you click on it, it'll behave as a drawer, or you can have it overlaid, which means that it'll stay on top of the panel. It won't push it underneath. Also, when it's collapsed, you can select it to have a compact version of the side panel. So it always stays visible all the time, only in a compact version. This is with the overlay version, and this is with the docked version. So now in VCL and in standard Windows applications, you can emulate the behavior that many of your users are familiar with mobile applications created for either iPhones or for Android devices. You can have it on the right, you can have it on the left, and by default it uses animation. You could see this is exactly trying to emulate the way it works in mobile devices. But if for some reason you don't want the animation, you have the custom option to eliminate it. Next component is a toggle switch. It's a simple visual component, but this was mainly introduced. If you have seen the Windows control panel, the control panel now extensively uses this new control to toggle on and off many of the settings of Windows. Well, you have this control available to use in your applications. It's a very simple control, but you can directly toggle it, or you can toggle it in code by toggling its property in code. And also you can change the caption that is shown on each one of the labels, whether it's on or off. So you have full control of the visual styling and how the toggle switch looks like. Now, in all of these sample applications, we remind you that you can also toggle the VCL styling introduced a while back. So all of these are available with the Windows styling. So you could see that this is emulating Windows 10 lookout field, and the toggle component changes accordingly. The next one, the last one, will be the daytime pickers. We already had daytime pickers in the past, so the point is that these components have been introduced to emulate the look and feel introduced by Windows 10. This styling was introduced, well, actually since Windows 8, but this is the standard look and feel nowadays for a daytime picker. This is the way any date and time is shown by the operating system and in the configuration dialogues and also in the control panel. So now you have these controls available in your application. You can, as usual, you can control many of the properties and the look and feel, the formatting and styling of the dates and the times on each one of the components. I have been showing you these demo applications in Delphi, but of course, you have all of them available also in C++. So I'll do just a quick recap just to show you that C++ Builder developers have all these components available immediately as well. So this is a recap of the components I just showed to you that are available in Delphi and C++ Builder. This is everything I have to show you. And we go to the questions and answers. And while we do the questions and answers, I will show you the resources that you can use to get more information about everything related to the Windows Runtime. So the first 4 resources are regarding documentation, the official documentation for Delphi and C++ Builder on how to use these components. I'm also putting a reference to the very excellent presentation done by Marco Cantu a few days ago, explaining this nightmare of the 3 APIs, how they made the marvelous feat of integrating that for us in VCL and FMX, and we don't need to bother about it. Also, I'm introducing the resource entry for CodeRage 11. There's an overview of the new Windows 10 VCL controls, similar to what I have been showing to you today by Ray Konopka. And finally, a skill sprint presented by Jim McKee called Unlocking the Windows Runtime on Windows 10. That was done in 2015, but still applies. So I just give you the latest status on the Windows Runtime and what's going on behind all the introduction of this platform. So, Jim, we go then with you for the questions and answers.
All right. So there is one here asking what was going on for you there. I'm guessing with the C++ builder part, you were getting an error or something?
Yeah, because of the crash of my the power outage, I had to restart my application. Let me see if I can just restart it quickly. But while I do that, do you have any other questions here?
So can the T-split view use touches on a touchscreen to slide open and closed?
Pardon me?
The T-split view can be used on a touchscreen for touches to slide open and closed.
Yes, of course. All of them are touch enabled. Actually, the car panel as well is also enabled by touch. So that means that all of them will work both on VCL. VCL, since a long time, has been touch enabled by its own. I mean, it's a feature added to the component, to the library by Embarcadero. And FMX, it's already from the beginning enabled, touch enabled. So yes, regardless you use the VCL version, which is the one I'm presenting here, or if you switch to FMX, all of them are touch enabled. So, and it is seamlessly being done by the framework. Again, one of the benefits of using Rat Studio is that regardless you use VCL or you use FMX, they all are touch enabled. So for these very specific controls, yeah, actually, I think that was the big feature that also you presented in your skill sprint presentation, is that with this introduction of these new components in Windows Runtime, the VCL could catch up with the FMX. And actually FMX later also improved, because at the beginning these controls were done with a rendering in FMX, but finally, if you are using Windows 10, now FMX is trying to use the native controls. But if not, it falls back to its own styling. But basically, if you're using Windows 10, it doesn't matter if you're on FMX or VCL. It will show these native Windows Runtime controls and will be touch enabled seamlessly for you.
Yeah. Also, FireMonkey has the for touch enablement. The FireMonkey has the what's it called? The multi-touch gestures, I think it is, that you can use. So there's gesture support with VCL, and FireMonkey added the multi-touch gestures, which works on Windows 10 as well, where you can do multiple touches on touchscreens, where you can do like pan and zoom and pinch to zoom and pan and all that sort of stuff like that. Because I think I've used that on Windows 10 multi-touch. I have a multi-touch tablet for Windows 10 that I use, but I haven't used it in a while, so now I can't remember for sure if I've done that. I'm pretty sure it does work on there, because if you have a multi-touch device. But most of us use Windows 10 via a mouse or just a touchpad, which is not multi-touch.
Right. Yeah. So
a number of people point out that this is a great presentation. I agree. Really good stuff here. Great to see. Everything working or showing up great, or all the stuff you're showing off and explaining. I like the I really got a lot out of the explanation you did about the evolution of frameworks and stuff like that. That's something I've touched on before. I don't know if I did it in that skill sprint you linked to or not, but just the way the frameworks have evolved and access to them and such. And really, I think that's one thing that's big and I think important about Windows 10 is that Windows 10 is really Microsoft recommitment to the importance of native apps, and that they're making all the Windows Runtime stuff available to native apps again. So it's one of those things that, Embarcadero first, or I guess back when it was CodeGear or Borland, they did Borland, they did Delphi for .Net, but then later it's like, okay, we're just going to double down and recommit to native development, and that's what really kind of won out, if you will, right? Is that bet paid off? Is that most people today are still using native development on Windows, and everybody else has stopped, really. And so it's like the only tool for native development is Delphi and C++ Builder today. I mean, Visual C++ is still fine, but it's not the same, in my opinion, level of polish that Delphi and C++ Builder had. Sir, is your demo going to work now? Do you want to do that?
Yeah, I was just waiting for this, but yes, basically, Jim, actually you've been the one presenting mostly since these Windows Runtime controls were introduced. So I tried to make it a little different by showing to the people the story of why it is important to us to know about the Windows Runtime. But finally, if you didn't know everything that I presented today, it wouldn't matter if you are a Delphi or C++ developer. You just simply can drop the component and use it. You don't know all this nightmare that is happening in the background, especially for those hardcore C++ developers that are still using Windows 32 because they need to maintain a legacy application created 15 years ago. These guys are really crying to Microsoft, hey, don't do that to us. So, yes, we are welcoming that you have now the Windows Runtime, that finally you are remembering about the C++ native developers, but don't do that to force us to change everything. So now that's why I put those comments by the Vice President of Microsoft Developers, is they are acknowledging this big complaint, and now they are back introducing these new features in Windows 32 API. But again, to us, as Delphi and C++ developers, it's something happening totally a part of our own universe because it was already solved by the runtime and the frameworks included in Delphi and C++ Builder.
Yeah. So Nicholas has a question here, and I might be able to add some things to this, but maybe you might have more. He says, I've tried to use parts of WinRT that don't have the nice Delphi wrappers, but I've struggled with the asynchronous nature of the calls. What is the recommended way to call those asynchronous API methods from Delphi?
In Delphi, you can just follow let me show you here. I had it here, but it was dropped. So bear with me for a second. I'll show you just the applications. So you can see that there's a special folder in the source code for the VCL and the runtime library. So this one has all the new interfaces in Pascal for the WinRT. So depending on the one that you want to use, you just call them. But you're talking about one asynchronous one.
Yeah, saying if one that's not already wrapped, trying to call it. What's the best practices for the asynchronous calling conventions that it uses?
Yeah, I would have to refer to him a special document created by Microsoft. But I wanted to show some of them that they are not wrapped. You can follow the example of how the runtime library is doing it already. I'm just trying to remember which component is making an asynchronous call. So following the way that was already solved by the runtime library in Delphi, it's a good example of how to use it for others, because the way the asynchronous calls are implemented in Windows Runtime is almost identical. They are following, this is something good that they did, is the way you call it on one routine is the same for any other routine or in another component or another class. So following the example of how it's being done in the components that are wrapped gives you an idea of how to do it well. Let me see, I don't recall right now which one, but we could post it later if you want on with the links of the source code that we posted with this presentation. Or we'll find one that is specifically calling asynchronous code and then give an example to them.
Yeah, okay. I'll put a comment here to look in that folder for the examples. That's definitely the best way to do it, but generally what I've done in the past, and I'm trying to remember I don't remember exactly how it's done here, but what you can do with an asynchronous call is you can use, with an asynchronous call, you have to say, when this finishes, call this event handler, right? And so you got an event handler, but then you can use a wrap it with a future or some other type of handler, right? That can then have your UI thread pause to, he said, he commented that WinAPI.media has a lot of asynchronous stuff in there. So you can wrap it with one thing you can do is put it in a separate thread and then have your API thread then pause on that. Although the reason that they want to, your UI thread pause on that while you're waiting for the asynchronous response. But the reason that they do this asynchronously is because you don't want your UI thread to pause. And so really what you should do is have an event handler that the asynchronous calls back to and then respond to that event handler so that your UI thread is never paused, which is a different programming model if you're used to the synchronous programming model, which there's a way to simulate that, but really it should be done that way. But anyway, I said WinAPI.media has the examples in it of asynchronous stuff.
But still, the question is very good. Actually, and frankly speaking, you didn't prepare for that specific question, but it's very good because you're talking about calling the Windows runtime. So you are not following the threads within Delphi or C++ Builder. Now you must follow the rules imposed by Windows runtime itself. So yes, you must follow the threading that they are imposed under the hood. So now you are on another level of threats. You are not on the provided by the runtime library of Delphi or C++ Builder. So there is some minor marshalling because the way they implement it is following the rule of the Windows runtime. Now, when you look at them, they're very similar to the way component object model was introduced. But if some of you have ever coded COM directly, meaning in C, the original C interface wasn't even object-oriented at that time. I mean, component object model is object-oriented, but when it was introduced, it was following the Windows 32 API. So yes, you were coding objects, but using a standard C API. So it sounds like cumbersome. So those codes were really hard to parse. And that's one of the main reasons why languages like Delphi and C++ Builder became so popular, because you could just come with a much easier way rather than going to the hard way and implementing those huge header files and codings for implementing just an interface and call a COM object model. And there was a complaint by many developers at the time. But yeah, other than that, Windows Runtime is easier, but some of the rules of how you call the interfaces and the threads are very similar to component object model calling.
There was actually, back in the day when COM first came out and Delphi had this great COM support, it was really common that people would use Delphi to do all their COM development. I knew a number of people that worked at large Visual Basic development shops, and they would be part of the Delphi team that would do all the COM stuff, especially like creating new ActiveX controls and stuff like that would be used by the Visual Basic developers. And it was funny because they'd be like, with the 2 Delphi developers you have, we could replace, 100 Visual Basic developers. You're like, no, we're a Visual Basic shop. You're like, no, you don't understand what we're saying here. Anyway, yeah, so Delphi goes a long way to, gosh, I will dig into this, Miguel, and we can follow up maybe with a blog post about this, but there was some stuff in here for making those calls that it made it actually quite a bit simpler. So I'll have to look into that. Maybe I'll ask Marco. So go ahead and do the demo part, and then we'll.
Yeah, but yeah, it's the question is very good. They actually didn't prepare exactly for that, but I think actually didn't think about it, Jim. This would be a good way to give a new look at this presentation, because I tried to make it not the same as the ones that you had presented before. But you're right, how to do direct calls for those features that are not already wrapped by the VCL or the FireMonkey libraries. Yeah, that's a good question. So you want me to show them how the C++ version works? Here are the same components. So it's just a quick demonstration. Exactly the same components that I showed them in the Delphi side work exactly the same in C++ C Builder. So you can have them and then click, and then it's been notified. And if you don't believe me, you can see here, this is C++. And they are called business as usual, the same way as you do with Delphi. You just call your visual components, drop them in your form, and you don't need to bother with all the hard coding of calling the Windows runtime. So I'll show quickly also activity indicator, which is in C++ Builder. We have the same visual components available. The relative panel as well. All of these can be found on your demos folder. If you go to either CPP or Object Pascal, and then go to VCL, you see the folders with all these codes there. Then in C++, here in C++ Builder, you can see the responsive application is working the same. No matter what I do with the form size, the control stays at the relative position that I set it to be at. And this stupid part. And finally, the split view, the one emulating the mobile applications.
I love the split view and the multi-view. Those are two of my favorite components.
Yeah, big improvement because many people knows or are familiar with this type of components, but because of the mobile applications. So finally, Microsoft had to do some reverse engineering and implement them in Windows. And good thing is that immediately were available in Delphi and C Builder because now the implementation was done by Embarcadero and added them.
And I'm noticing here as you're running this, there's a little bit of choppiness to the way it's painted, but in person, I know that looks beautiful because I've used that before. That's just the way the webinar is. And I found out the technical term for that button there with the 3 lines is a hamburger button. And if it's 3 dots, like you usually see up in the upper right-hand corner, that's the shish kebab button.
Yeah, you're right. Now I seen also they call him the hamburger. Previously was called the master button or the master menu button, but nowadays they're calling it the hamburger button.
Yep, which I think is funny. And I actually have seen applications where the hamburger button is a picture of a hamburger.
Yeah. So, well, basically that's it. That's just showing that in C++ Builder, all these components work seamlessly with no change. So that's one of the beauties of the VCL is you have your choice of using either Pascal or C++. The application will work the same seamlessly and regardless of your choice of the programming language.
Okay. Well, I think that's it for questions. I appreciate everybody joining us today. And Miguel, thank you so much for putting this together. We will, Nicholas, I'm going to give you my email address here, and you can email and follow up. Email me, and I will let you know when Miguel and I have that blog post.
Yep.
Thank
you very much.
Using those directly.
Yep. Sure.
And yeah, so that'd be a great idea. We'll do that. I'll ask Marco because I think he had some resources on how to do that, and then be a great blog post to follow up with this. So.
Sure, and actually you're right, James. And I think it might be easier if you just get some quick reference from the guys that implemented the VCL with these components. They had to actually do that. So that's what I tried to do right now, but I wasn't prepared. So I've seen some components where the callbacks are done directly in the VCL, following that architecture of asynchronously calling Windows Runtime functions and interfaces. So following that is a good example because it's been tested, and now we're talking more than 5 years since they went into do, so they are polished, and that's a good model to follow now.
Yep. So I put a link back in for the full Windows 10 Modernized webinar series. I don't have the webinar that's going to be next week with Microsoft on there yet, but do check that out. Follow our social media, and look to your inbox for notifications about that as soon as we have it posted. It should be posted really soon. It took a while to get that scheduled with Microsoft, but we're one of their I can't remember the guy's role. He's going to be working with us on that. It'll be a joint presentation with Marco, myself, and this guy from Microsoft. So should be really, really good. We'll be talking about a lot of the great things in Windows 10, and hope you'll join us for that. So thanks so much, everybody, and we will talk to you later.
Thank you. Bye.